Hello everyone, I am the Weather Dude. Welcome back, and today we're going to be taking a look at Invest 96E over in the Pacific side, and we're going to be seeing the chances of it developing and what potential land areas it could impact further on down the road. Before we get started, however, be sure to like and subscribe, as it only takes a few seconds and helps my channel grow, and also be sure to watch the whole video so you get the most out of this weather forecast. And let's get started. Now, technically, there are two disturbances over in the Pacific Ocean, and the other video that's going to be coming out today will be about a disturbance that just formed in the North Atlantic. The other thing with the other Pacific disturbance, though, is I notice how there's not an X, right? So the X is for this disturbance, but there's no X for the other one, meaning we don't know where the low center for the other disturbance is yet. So we're going to save that for when the low center eventually emerges into the ocean. But for now, I mean, both of them have a very high chance of development. This one is Invest 96E, and it has an 80% chance of development, 800 miles south-southeast of the southern tip of the Baja California Peninsula. And it's a small but concentrated area of showers and storms. As you're going to see on the models later, it's a pretty small system. All right, environmental conditions are favorable for development, and a tropical depression or storm, they're just saying tropical depression to play on the low side. It's a depression or higher, is likely to form in a couple days when the low moves west to west-northwestward at 10 to 15 miles an hour. Now, you might think, okay, west or northwest or west-northwest, who cares? The direction is actually going to matter a lot, and you're going to see why. So the 2-day formation chance is 60%, but 5 days is 80%. So maybe between that 2 and 5 day time frame. So depending on how the environmental conditions are coming together. The storm strength right now, it is 30 mile an hour sustained winds. You're not getting a reading on the gust. 25 knots is the current maximum sustained winds. Pressure is about 1,008 millibars. And the maximum wind, which is 30 miles an hour, goes out about 80 nautical miles from the center. And if we look at the satellite imagery right now, you can sort of see Elsa kind of had a similar theme to this, in the sense that you can see the rotation, but the convection is like the most intense convection is right over top of that circulation. This could be more like mid-level circulation, but you can see it's definitely swirling, right? You can see it, but the convection is right over top of it. So that means that the storm is not really stacked well, although we are starting to see a nice flare-up of thunderstorms near the center. I mean, that's pretty good to see as well. But notice, I mean, the area convections, because I zoomed in, it looks kind of big, but in reality, it is pretty tiny. The convection goes from about 15 degrees north down to 12. That's really not that big, all right, in terms of latitude speaking. So that's not a very big system. Now, looking at the sea surface temperature anomalies, so I'm going to zoom in here because it's on the right side. And you can see where we're sitting at right now. The coordinates are about 110 degrees west, and maybe between 10 and 12 is where the center is. So we're pretty much sitting in this zone somewhere. All right, maybe a bit further south than that. So we're sitting in some above average waters, right? Now, if it were to move west-northwestward, notice how it moves into that colder water. Whereas if it moves due west, or even just west and possibly a little bit of west-northwest, like in this direction, it might stay in those warmer waters for a bit longer. And obviously that would help its development. Here, I can better explain it on this map right here. We're going to go back to the other one in just a second. So you can see, either way, we're in some pretty warm waters right now, right? Definitely above 80 degrees. Notice how if it goes west, right, if it goes due west, or even just a little bit west-northwest, it stays in those yellow zones, right? The yellow means about 77, 78 degrees Fahrenheit plus, which is okay for development. But notice if it goes northwestward and it quickly runs into those greens, which is not so conducive for development. So that's why I said earlier the direction of movement is very important. Now, as for the sea surface temperature, not the anomalies, but the sea surface temperature trends in the past 7 days, you can see that we have trended, I would say, somewhat higher, right? And that means that obviously the waters have gotten a little bit warmer over the past week. And of course, that means the waters probably won't be tanking below average anytime soon if they've trended up over the past 7 days. So that's obviously a good sign for the system as well. So looking at the current low center, this was as of 2 o'clock this morning. It has definitely moved a little bit further west. It's only moving about 10 to 15 miles an hour, which is pretty much normal. Sitting at about 106.5 west and maybe just under 12 degrees north. But I think by now, personally, I think the low center is probably, I would say, right about here. It has moved a little bit since. So of course, if you want to look at the National Hurricane Center, there's your low center spot right there. Now, Looking at some of the model track guidance. Now, one of the models that I will be showing you, we got the GFS, Canadian, and Euro. One of those models is going to show something like what these models are showing later in the video. I won't spoil it, no spoiler alert. All right. Now, it's going to be moving northwest according to these models, and then pretty much making a west, maybe even a west-southwest turn. Now, it's not very often you see storms moving southwest. It's kind of weird, and the angle that they move in can actually sometimes impact the way the thunderstorms are formed around the system. Because usually, like, they can move north, northeast, northwest, west, east, but you don't really see them moving south too often, especially in the northern hemisphere. So that's, but it could be moving northwest and then kind of like due west, pretty much beelining it. Well, I wouldn't say beelining it, but heading towards Hawaii even, which down the road, that's going to be the landmass spot that I just talked about earlier. That's going to be the area that might have to watch out, right? Because there's really not many other land areas besides Hawaii that's sort of in the path, quote unquote, of this system. And looking at some GEFS model tracks, even though I just set this up, I want to make sure I got the latest here, so refreshing. All right, and you can see, again, pretty much like a northwest path. Then after 48 hours, up to 48 hours looks pretty confident. And then after that, the cone, if you will, quote unquote cone, kind of gets a little bit bigger if I'm drawing a cone around this. And you can see, and some of the models in that time frame between 48 and 96 hours, notice how we see the blues and the greens change to yellows. So it means the pressure is going down a little bit. And that's also a sign of strengthening. But it could be moving northwest, then potentially due west, maybe even west-southwest, as these models are pointing out. Same thing with what these model tracks were just showing. Now, the GEPS model tracks show a similar thing, moving northwest, then changing to due west. All right. So pretty much a cone sort of like this. It's a big cone. And the bigger cone around that means that the models are in disagreement more. There's less certainty, meaning more uncertainty. But you can see the general direction of movement by the models between the GEPS ensembles, GEFS ensembles, and more is definitely in somewhat of an agreement. And as for the intensity, I'm sure you're wondering about that. All right. Now, intensity, keep in mind that it could go higher than this. It can go lower than this. This isn't an exact depiction because I got news for you. Elsa was supposed to be a 60-mile-an-hour tropical storm, and a lot of the models were saying that, and it ended up becoming a hurricane. So just keep in mind that I would say expect possibilities that can go higher and expect possibilities that can go lower. But this is just a general gauge, and as of right now, that gauge is for it to become a mid to high-end ranking tropical storm, just shy of a Cat 1 hurricane. That most models that have it becoming a tropical storm. But notice, once it starts to move in that west-southwest direction, notice how it drops off again. Like I said, when a storm moves south, whether it's southwest, west-southwest, it can sometimes disrupt the way the storms are formed around it because of the direction of movement. So that can mean weakening, and we might see the peak strength between 48 and 96 hours, or 36 and 96 hours from now is when we could see our peak strength. So just keep that in mind as well. All right, moving on to the models. We got the GFS, Canadian, and European, as I said earlier. Focusing on this one, all right, this is our other system. Because the low center hasn't been identified by the National Hurricane Center yet, we're going to wait to talk about that one. But our first one is right here, all right, right in the middle of your screen. And you can see as it moves west, the storm might look a little bit bigger right now, and the convection is a little bit more disorganized around it. But watch in about 30 hours or so, and you can see how tiny it is, right? It's a tiny system. But in the middle of that, you can see some high vorticities, all right, on the cyclonic vorticity scale. And even notice where it is, right? I'm going to show you. It's around 120 degrees west at about, what is this, Thursday morning? All right. This is Saturday afternoon, and it really has not moved much. So it might slow down a little bit, and that's because it might lose its steering current, and then it might pick up again. All right. So you can see the potential for it to pick up. Now, for some reason on the GFS, it skips from 144 to 174, so it makes it look like it's going faster. But this is 6 days out, and you can see there's the second system behind that, all right? And then the other one, this is skipping ahead 30 hours. So this is Tuesday afternoon. Notice how it's on that southwest movement, which could disrupt its strength a little bit, all right? So looking at the sustained wind speeds now. Now, because A, the system is small, and B, the map is zoomed out a little bit, it's going to be hard for you to see the colors, but I can see them pretty well, so I'll be able to show you guys. And if I were to zoom in on the system for this, it kind of like glitches out because we have to wait for the new model runs to come in. So you can see the greens. I know it's hard for you guys to see, but the greens have formed right around here. Pressure has dropped to 998, which is typical for a tropical storm. So we have a tropical storm that has formed here. This time frame, I would say, is about late Wednesday into Thursday. Notice how the pressure starts dropping. It slows down. It's able to gather the environment that it's in. It's able to sit in that better developing environment, so it strengthens. Now it's down to 988, right? But then once it starts taking off again, and once it starts in that southwesterly movement, west-southwesterly movement, it sort of kind of decreases in strength, if you will. And then the other system is pretty much moving due west the entire time, so doesn't have to worry about moving south there. It's going to be fine. If a storm were to move south in the southern hemisphere, that wouldn't be as uncommon because obviously the hemispheres are flipped. But in the northern hemisphere, when a storm moves west-southwest like that, or southwest, or even south, that can sometimes disrupt its development a little bit. I see this happen more in the Pacific than in the Atlantic. All right, so looking at the wind shear anomalies. All right, now wind shear anomalies for the next 5 days in this particular zone are above average. All right, now that doesn't mean that it's high necessarily. It just means that it's above average, and it's according to the GFS model. All right, now looking ahead to the Canadian model here, again, there is our system right here. Now they have it going a bit farther north, right? The track is a bit farther north. Now what does that mean? Well, as you can see, it's not as strong because it was moving northwest at first, so it hit those colder waters a little bit faster. And then it's weakening even more once it starts in that southwesterly movement. Even though it's heading into warmer waters, the storm gets very displaced and disorganized, and it's kind of like backwards, if you will. All right, so then it moves, and it's over here on the left side of the screen, and it's pretty much dissipated. But then, of course, we have another system coming behind that, maybe even another system behind that. But that's pretty much long term. Now, does the Canadian model have it forming into a tropical storm? The answer to that, I would say, is no, because the lowest pressure it gets to is about 1,007, right? No, look, here's the low right here. It's a surface low, but you can't even see any greens around it at all. Like even I can't see it. So definitely not becoming a tropical depression. Could still be at hand with the Canadian model, but this latest run here, the 12Z run, does not show tropical storm development. But of course, if that heads towards Hawaii, that's still increased moisture, so gusty winds, and that could still impact Hawaii, even if it's not a tropical storm. If it doesn't have a name, don't take it with a grain of salt, as always. And of course, similar to the GFS model, shear out here is above average. Maybe once it gets farther west, the shear might drop to more average levels. But either way, the shear is not very high here because conditions are conducive for development. It's just above average for what it would normally be for this time of year. All right, moving on to the European model here. All right, as you can see, our system that we're watching is right about here. So this is this evening, about 8 o'clock p.m. All right, now we're moving, so each click advances the day. So this is 8 p.m. Wednesday, and by 8 p.m. Thursday, the European has an interesting low-level circulation going on there, and keeping at a decent strength. We're not strengthening very rapidly, but moving towards the west, and then in the last couple of clicks, look how those darker reds start to build in. The storm gets tighter, it gets a little, the storm decreases in size, and that means it's compacting together and strengthening. And you can see those higher vorticity values, and then the other system that is behind that. All right, so European model has a pretty strengthening system. All right, you can see it as it gets out of the frame here. Tropical storm. Now keep in mind, these are 5,000 feet winds, but these winds, either similar strength or just slightly weaker, can translate to the surface. So even though the 5,000 feet winds might say 60 miles an hour, maybe 40, 50 mile an hour surface winds can be expected here. And then of course, we have the other system sitting there behind that. All right, so I was able actually to get the zoomed in version, so we can see this is the GFS model like what we started with, except it's zoomed in, and it's gonna like home around the storm, so it's gonna be tracking the storm, so we don't have to like, it's not gonna move around the map, it'll always be in the middle of our screen. And before we wrap up here, I just want to show you now, you might be wondering, why do you have the relative humidity map on? And I'm gonna explain why. So you see we do have these darker greens, which definitely means increased moisture, we know that. But also, the reason I have it is because you can see the winds and how the winds are changing. So of course, we have this low, right? The surface low is right there, 1,009, you can see it pretty well. But then these arrows that you see pointing, the direction that they're pointing in, the straighter edge, is those mid-level winds. And notice how the mid-level winds, they're kind of going around the storm and then like this way. meaning that it's got like a half a circulation. The storm is not stacked very properly. The surface low might be going like this, but then the mid-level winds are just going like around it, but they're not fully wrapping around the system. And that's what we're seeing right now. That's fine. It's still at its beginning stages of development. But I want to show you, and for some reason you can just see this better on the relative humidity map. Now look at what happens. This is Wednesday night. Notice how, again, we have the low-level circulation going like this, the surface low. But then look at the mid-level circulation. If you can see those sticks pretty closely, they also wrap around the system now, meaning it's stacked properly. This is the trouble that we had with Elsa, because we had surface circulation doing one thing, we had mid-level circulation doing another thing, and it just wasn't stacking properly. But we see that here as we head further out in time. And even further out in time, this is by Friday morning, look at the mid-level circulation and the low-level circulation are pretty much lining up exactly. And the low is right in the middle of that circle. In the middle of the low, we have slightly less relative humidity, but still higher relative humidity. Now, what's also interesting is that we do see a little bit of dry air in the same motion of those mid-level winds. So maybe a little bit of dry air might get wrapped inside. We're going to have to watch that. Notice how you can see that. This is by Friday night. You can see it's starting to get in there a little bit better. So if dry air wraps in there, it could reduce the convection a bit more. And I think that's also why it's going to be starting to weaken. The dry air, look how much relative humidity it lost. This is by Saturday evening. You can see the dry air is pretty much dominating the eastern side, right? The eastern side and the northeastern side is supposed to be the dangerous part of the storm. And look, we just lose all the relative humidity here by Sunday evening. It's pretty much just become a dry low with a little bit of moisture left. So that could also be another reason why it could weaken. So maybe getting to its peak strength, maybe 48 to 96 hours out, and then potentially weakening. So that is it for today's video. I do have my other video coming out about the disturbance in the North Atlantic, so be sure to check that out. I am the Weather Dude, signing off. Till next time, I will catch you guys in the next video.